Hello and welcome back to our C# 8 tutorial. We are exploring today pattern matching enhancement. It's a feature that takes a conditional logic in C# to the next level. Actually, this feature was introduced in C# 7. C# 8 just expand on it by introducing more expressive pattern, including property pattern, tuple pattern, and positional pattern. So what exactly is a pattern matching? Pattern matching is about comparing a value against a pattern and taking specific action based on whatever the pattern match or not. It's like asking, is this object a rectangle? Or you can ask, does this tuple have these specific values? From database, tuple is just a row. And does this property satisfy certain conditions? So in C# 8, pattern matching has become more powerful, making our code less verbose and more. So let's see exactly what the enhancement in C# 8. Here, from my point of view, it will be 3. Property pattern, which basically match based on the value of an object properties. Checking if an object property meet a specific condition. Second, it will be with tuple pattern, which is gonna match value in tuple directly. Example like checking if a combination of values satisfy a condition. And latest, positional pattern, that one gonna match pattern based on the order of the constructed values in a type. Example, deconstructing and matching properties of a record or custom type. Let's move to Visual Studio and start by property pattern, which basically allow you to match object based on the values of their property. So here we have a class called person, which have 2 property, name and age. And inside the main, we're gonna have an object of the person, his name Alice, and the age is 30. And here we are actually using property pattern, which is gonna be the object, in our case gonna be person, and we are using here this basically the syntax of property pattern to check the person is, and here whatever your condition, age is greater than 18, name Alice, whatever. So that's basically you're checking here, and if this one gonna be success or true, he will say okay, Alice is an adult, otherwise he will say no match found. Let me execute this application. In our case, age is 30, so he should say yeah, Alice is an adult. Next, let's have an example on tuple pattern. And first, we have here a coordinate of x and y, and this coordinate with this point 0 and 5. And as we learned, tuple gonna check with multi-value. So here tuple coordinate is created with 2 integer, x equals 0 and y equals 5. And as we know, tuple are data structure that group multi-value together. Perfect. Here, as we learned before with the new switch statement in C# 8, that gonna use a different syntax to evaluate a tuple against your pattern. So here we don't have, as we learned before, no more case, no more break, no more default. And here we have this inside switch, which have some pattern. Each pattern in the switch expression represent a condition to check against the tuple view. The first pattern here, 0 and 0, that one gonna match if both x and y are 0, which gonna represent the origin of a certain. Okay. The next one, or the next pattern, which is gonna be match in case that if x is 0 and ignore the value of y using this underscore. Okay, which means that your point represent this pattern. And the vice versa, if your y is equal 0 and gonna ignore the value of x. And the last one, which is basically the default, gonna match any tuple that doesn't satisfy the early conditions, which gonna be, you know, a fallback case or whatever, يعني something else. So evaluation for our process here inside the switch, as we can see that 0 gonna definitely here x equals 0, so gonna go with on the y-axis. So let me execute this application, and here you can find this was the right answer. The point is on the y-axis. Great. So why the tuple pattern are useful here? As you can see, our code is much cleaner, more concise. We replaced nested if else if statement with a single switch expression. We eliminate the need of, you know, tuple manually. It's more expressive. As you can see, we clearly define conditions in a readable and maintainable way, and definitely it's efficient because you can evaluate pattern sequentially, stopping the first match. And by the way, this one is very useful for real-world application of tuple pattern. It's widely used with game development to check points of the game object, specifically in 2D and 3D grid. If even you are working with geographical coordinates to determine the region based on latitude and longitude values, it will be very useful for you. Even, you know, for people who's working with data science and data classifications to categorize data points based on multi-dimension, it will be a great additive. Let's move to positional pattern, the last one in this session. Here we have a class, call it circle. You know, circle, by end of day, it's about only one property, radius, which is gonna be definitely double. And we're gonna use the constructor to initiate this radius. And here we have the construct. That one we can say to include the deconstructor method, which enable, you know, the circle object to be broken down into component. In this case, radius, because deconstruction process, it's a breaking an object into some parts, allowing a pattern to access these parts directly. In our case, we just have radius. Next, here inside the main, we will initiate an object from this class circle with a value 5 for the radius. Then we're gonna have the normal switch statement that we learned about it, which are gonna have here 3 cases. The first case, we are checking your radius. If it's greater than 10, it means that this circle is large. If it's like medium, so it will be from 5 to 10. Other than this, which would be 1, 2, 3 or whatever, it will be small circle. So the idea here, we are extracting inside the deconstructor method, we are extracting the radius to go and check. So let me execute this application. In our case, it will be small circle because 5, it doesn't match the first case, neither the second case, it matches the last one. So let's say why I have to use positional pattern, or why it's useful. Because it eliminates the need for manual property access or method call to get values, as long as we are using deconstruction to extract our data directly. It's even more readable. As you can see inside the switch expression, we can evaluate directly our pattern, which improve maintainability in the future to extend or modify or add new pattern or condition. So let me show you the old way of manual access to the radius property. In the old days, we used it to go and click here circle.r to fetch the radius itself. And we're gonna go and check throughout if condition, which are gonna be if circle is greater than 10. In that case, we're gonna put here even one more variable. We can call it description, or we can directly print on the screen console.writeLine large circle. This will be the old way or the classic way. Again, you have to repeat with else, but we have one more condition, so it will be else if circle.radius, and here again console.writeLine, and you have to bring medium circle as you can see, and one last time with the else, which it will be console.writeLine. In our case it will be small circle. As you can find here, this one have a drawback because you're gonna go to manual access to the radius property, which is not good, and you can see the verbose and less expressive. So with potential pattern, the same logic is more concise and much elegant. And as well, this one is very useful in game development to handle game objects, characteristics like size, speed, position. Even with data modeling, you can match object based on a specific configuration or threshold. So even with shape geometry, you can classify geometric shapes like circle, rectangle based on their dimensions. So back here again, we explored the powerful pattern matching enhancement introduced in C#8. As we learned together property pattern, which gonna work matching object based on their property, tuple matching, which gonna evaluate multi-value for more precise logic, and the last one, positional pattern, deconstructing object to match a specific shape or configuration. By leverage this pattern, you can simplify complex condition logic, reduce code complexity, and write more maintainable application. As you practice this concept, think about how they can enhance your existing project and make your code more readable and efficient. And see you in the next video.